Hi everyone, welcome to this section of R programming where we will learn about functions, whether that is about inbuilt function or creating your own functions and working on your different data structures. So what are functions? Function is basically a set of statements to perform a specific task. Now R has a large number of inbuilt functions, or you can say packages, which you can import and start using, or users can create their own functions. So when it comes to functions, the syntax is very simple. You give a function name, you can assign your function to a variable, and a function can take no arguments, one argument, or any number of arguments. So let's see some example on functions. So for example, here we are creating a variable called squares and we are assigning a function to it. Now this function would take one argument, which is a, and then we use a for loop. So we say for I in from 1 to the number a, we would basically be doing a exponential computation. So what we would do is we would square the value in this particular range and assign that to b and print it. Now when we do this, we can call in this function and pass in a value to look at the square of that particular value. Now this is a simple example of function. So this is how it would look depending on what value you have passed to the function. So for example, we say squares and we pass in a value of 4. So that becomes for I in 1 to 4. So you would start with 1. The value of 1 square would be 1. And then you have your value for 2. So 2 square would be 4. Then we have 3. 3 square would be 9. And then we have 4 square, which is 16. This is a simple example of function. And this is how you can create your own function to calculate or carry out some computations. Now let's look at some other examples before we get into built-in functions, which basically allows you to work with different data structures. So there are different mathematical functions which can be used for your data science or computations. You have your regular expressions which can be used for pattern matching, or you can also use functions for data manipulation. Now, before we get into data manipulation, let's look at how you work with functions, taking some examples. So let me bring up my R Studio, wherein we will try out some examples and see how functions work. Now, here are some examples and we can see how this works. Let me just clean up the console and we can start here. Now here we are creating a simple function which does not take any argument. We call it as hello world, and this will start with the word function and parenthesis. Now that could have arguments passed in. However, this function, we are not passing in any argument. And what we are doing here is we are printing out whatever value is passed within the bracket. So let me just do a control enter. My function is created, and you can straight away call this by just doing this. Now, however, if you would have tried this function without the bracket, for example, something like this, then it would have printed out the complete function. It would have printed out the complete function and whatever you passed in to hello world. But if you would want to call the function, then basically you would just do hello world and then use the brackets. So that's how you call the function, and that's how it shows the result. Now, your function can be with a single argument. So for example, here we are passing in an argument called name, and we can then use this to pass a value to this. So here I'm saying hello name. I have my function, but this one takes a single argument, and we are going to use paste, which basically can concatenate or just adds up whatever you are passing in to paste. So we will say paste hello and then the name. Notice that I have given a space here after hello so that I can have it in the right format, and I can just do this. So the function is created, and now let's pass a name here and just try to call the function. So name is one argument or a single argument which is passed to this function. So let's look at the result, and that shows me the name whichever was passed to this one. Now, what we can also have is function created which takes two arguments, and this is a simple example. So here we are creating a function addNum. I'm saying function, it takes two argument. I'm not providing any value or default values for this. We'll see some other examples for those. Now here, this particular function takes two arguments, and whatever you pass in here, a addition of that will be seen. So let's create this function and let's call it and test it, and that shows me the result as 70. Now what we can also do is we can add a vector to a number. So vector is list of elements or list of objects, you can say, and here we would want to perform addNum, or we would have to call addNum function by passing in vector, which becomes the first argument, and the second value is the next argument. So let's run this one, and that shows me the result wherein 5 as a value has been added to every element of this particular vector. Now when it comes to function, you can also have default argument values which can be passed. So here let's look at as an example. So we have hello name again, but this time instead of passing in just an argument, we will also provide it a value, or you could say that could be considered as a default value. Now when we create this function, we are doing the same thing as previous examples, but we are passing in an argument, and that argument has a value. Now once I do this, I can surely call this function without passing in a value, and that shows me the name which we had assigned to the argument, or we can even pass in a new name which will be assigned to name. So if we do this, it works in both the ways fine. So this is in one way you are passing in a default value, and then basically you can either call the argument or you can assign it a new value. So if we would do something like this, hello name, and then for example I would say name equals say Jerry, and if I would do this, so that also works fine. However, since we are passing in an argument, we are assigning a value, so either we can let it go for the default, or we can just pass in the value, or we can be very specific in mentioning the argument and then the value for it. Now how do we return value from a function? Let's look at this. So here we are creating a function, we are calling it full name, and this one takes name wherein we are giving Sachin, and title is say Tendulkar, and what we would do is we would use a return statement here. So return would basically use the paste function. It will take the values of name and title and then glue them together. However, we are using also a space so that there is a space between these two values to the arguments which are passed. Now if I run this this function, my function is created. Now we have already passed named arguments, or we have already passed value to those. So we can straight away say just call the function, and that does whatever you have mentioned in the function body. I could have also said that I could create a new one wherein I will pass new set of values which we saw in a previous example, and then if we call this, it takes up the new values. So either you can let it go for default like what we did here, we can also pass in new values, or if you would want to keep it specific, you could basically say full underscore name, that's my function. I could say name equals, and I can say John, and then I will say title Smith, and that's also fine. So we can do this, and that works in the same way as it would have worked with just passing in the names. So this is fine. And if you would want to test it out, say for example, if I would just take off name here and just do this, that also works perfectly fine, wherein we are still using these arguments in the particular order. Now if I would have changed this one to name, wherein I am already passing in a value for name. And if I tried this, so in this case, what happens is name is Smith and basically your title becomes John, right? So we have to remember what arguments we are passing, and if we are basically assigning values to the arguments or letting it pick up the default ones. So let's do this, and that looks okay. Now, when you talk about scope of a variable, okay, now before we understand scope of a variable, let me show you some more examples on function. Now, say for example, if you were using built-in functions, we have lots and lots of built-in functions which are available for programmers, which they can use in their data science activities or data processing or computation. Now here we are using a function called rnorm to generate 1000 random values from a normal distribution of mean 0 and 1. So I would use the rnorm, that's an inbuilt function, and I will call this, say, normal distribution. So that is already done. Now we can find out the mean on these random values which would have been generated using the inbuilt mean function, and that works perfectly fine. You can also create a histogram out of this, and if I do this, it shows me the histogram. So let's see the histogram here. Let's bring it out, and that shows me the histogram of normal distribution. If you would be interested in knowing about a particular inbuilt function, you can just do a question mark and use the function, and that basically shows you the documentation of the function. So this is a generic function which computes a histogram of a given data value, and here it takes arguments. So this is basically your data. This could be the number of arguments which you are passing in for your histogram to be created. Now we can look at some more examples here. So I can say to histogram with large number of interval breaks, and this is where I'm also specifying breaks and passing in a value. So this allows me to provide arguments to functions by position. Now the same example which we have given here, we can do it without breaks argument, but as a good practice, we should actually give name to the arguments which we are defining. So if I would do this, wherein I'm passing in my data, that is normal distribution, and then for breaks, I'm just giving the value 50, and that is also fine. It works perfectly fine here. Now we can create our own function, which, as we saw in some basic examples, functions which can be without arguments. Say this is a simple example, or with arguments. So this one we have already seen how you can create a function without giving any argument, or by giving an argument and then basically calling in the function. Now when it comes to optional arguments, so we can look at this function wherein I would want to say find out the exponential value of a particular number. So I call it expo value. I use my function. I say this will take the value x. Now that's an argument which we are passing in. We could have given it a value, or we will just let the user provide the value when this function is being called. I will also give a default argument which is power equals 2, and here we would want to get a histogram of the values with a particular power. So if I create this particular function, that's done, and now I will just pass in my value. I don't need to mention power, that has been given a default value. Yeah, if we would want to change it, then we can pass in that. So let's run this one, and that gives me exponential value, a histogram based on the normal distribution data, and by default it is using power as 2. Now, what we could have also done is we could have specifically mentioned a different value for power, and that works perfectly fine. I could have just passed in the value as power, and that also works fine. So here you are using named arguments and basically passing in any other arguments. Now, what we can also do is we can use these named arguments, and then we can also do or we can pass these arguments. That is what we call as passing any other arguments. Now, if you look at the explanation of this histogram function, if we look at this, it shows me these three dots, and this is what we can use to pass in any other arguments. So let's look at an example for this one. So say for example, I would want to create a function where I am passing named arguments. I am passing in the data, but then I would also want to pass any other arguments which can be passed dynamically. Now for that, we can create a function here wherein I'm calling it expo value again. I'm passing in my x, which will be the data which we will pass in. You are mentioning power, which is 2, which is a named argument, which can also be considered as a default, or you can change the value, or you can provide a new value. And then I'm also giving these three dots, which are also passed in within this particular function. So let me create this function here. Now, once that is done, then I can call this function by passing in my data, which is normal distribution, power is 2, and then I'm also using these breaks for getting my histogram with intervals of 50. So let's call this function, and that gives me the histogram. Now, what we can also do is sometimes it might be useful to pass logical arguments. So for logical arguments, what we can do is we can create a function which will take the data. Here I'm using a named argument exp, that is for exponential. I'm saying if the value of histogram is false, and then I'm also giving any other arguments. So what we'll do here is in this function, we will say if the value of hist is true, then this block of code will get executed where you will get a histogram based on the exponential which has been assigned in the function passed as an argument. And if that doesn't hold true, which is by default false as we have given in our function, then this piece of code will get executed. So let's create this function, and that's done. And now we can straight away just pass in our data. Exponential value is given as 2. Histogram has been given in false. That means the else part of the code will get executed. And we can look at the values here. I can also say histogram is true, and that's where we will be calling in the hist function, and I can do this. That shows me the histogram. So in this way we can pass in named arguments, we can pass logicals, and then we can also pass any other arguments for our use case. Now looking further in functions, let's also understand the scope of a variable in a function. So here I am saying v, and then I'm saying I am global variable. Let's create this. And then I'm saying stuff. So I'm global stuff. So this is basically we have assigned some values to variables v and stuff. Now let's create a function where I'll say fun. I'll use the function and I will say this will take my variable stuff. I'm saying print v, and then for stuff I'm assigning in a new value, and then I'll print stuff. So let me create this function and let's see how it works. So if, for example, I would just say print v, that shows me the global variable which we had created earlier. And since I'm using that within my function, it basically has the value. Now I also have a global stuff. So I'm saying print stuff, and that shows me whatever was assigned to the variable. And now we will basically call the function by giving in the argument as stuff, the variable which we had created. Now, if we do this, then it says reassigning stuff inside the function. And that's because within the function, we are basically assigning a new value to this stuff. Now, I can also just do a print stuff now. If you see, it still goes back and prints the global variable. So only within the function, reassignment happened, and that's what we understand when we talk about global variable or local variable. Now, to create a function to find the final amount to be paid by a customer after adding 20% tax to the purchased amount. How do we do that? So I'm here creating a function which will take x as 100. And what does that function do? We would want to basically find out the amount which is paid by customer after adding 20% of tax. Now, how do we calculate that? So we take x plus 20% of x, and that would be the final amount which will be paid. So we do a return t, and this is my function. So let's create this function, and then let's pass in a value to see what is the amount which customer would pay with an addition of 20% tax. So this is a simple function where we are passing in one argument, we are giving it a value, and then we are doing computation within the function body. What we can also do is we can create a function where I am passing in an argument, and I can then check the value of that. So if the argument passed was greater than 0, then we would find out the final amount, which is amount plus 20% of the amount. If the amount is less than or equal to amount, then equal to 0, then our final amount is equal to amount, and we return f amount. So here we will be evaluating these conditions, and based on that my function will return the value. So let's create this function and pass in a value, and that shows me 100. So you can just test this by saying amount 1, and say for example I would have passed in 0. Now in this case my final amount is 0 because there is no amount which needs to be paid by the customer. Now checking the argument and the body of a function. So we can always use this inbuilt function args, which will tell me for this particular function what are the arguments and what is the body of the argument, which basically tells me whatever we have coded within the function body. Now to understand the scope, we can create a function here which is taking an argument x, and what does this do? So we assign a value to y, then we basically say g1, and here I am using function of x. Now what does that function of x do? So this one will take the value of y plus multiply x by itself. So this is a function which we are creating, and then I am saying g1 of x. So what you're doing is whatever value was passed in as x, for that function x will be applied. So let's create this function and then pass in a value 10, and that gives me the result as 110. Similarly, we can create another function where we want to do some computation, and then I'm creating one more variable which has basically the function, pass in a value for y, and then basically what you do is you are calling in your g2 function, and then let's call in this function. So let's do this, and let's also create f2, and then finally we will call in f2, which is internally calling g2. So these are some simple examples where you are doing some computations and creating some simple functions. Let's also create a function which is taking two arguments. So here I have g2 function takes two arguments, x and y. What does that function do? Here we are saying y plus x into x, that's my g2. And similarly, I'll create f2, which is going to have a value assigned to y, and this one is going to call in my g2 function, which will take x and y, x which we are passing in here, and y which we have assigned. So let's create this, and then let's call our f2. And what does that f2 do? It basically has the value of y assigned, and then it does whatever is mentioned in g2 with our x and y values. So I'm passing in 10 here. So it is basically y, which is 10, plus you have the x value which has been passed here. So let's look at the calculation, which is 10. So that gives me 110. So 10 into 10 into 10 plus the value of y. So this is how we can create functions which have been assigned some values, and then pass in some other values to those. Look at some more examples here when we work with functions, and see how we can use functions to carry out our basic operations or calculations. So for example, here I'm creating a function, and this will take an argument wherein we are saying it would be marks. Now let's do this, and the function body would say result is not defined. Now if the marks are greater than 50, then result will be pass, and you will have the message which is your result is, and then you are passing in the value of result. So let's look at this one. So let's create this function, pretty simple function, and then let's pass in a value here. So I'll say status as 60, which will be checked for the value greater than marks or lesser than marks, and that tells me your result is pass. And if we give this one, then it says your result is not defined. However, we can have additional statements here which can say if the result was lesser than 50, then what should have been printed. This is a simple example. Let's look at one more example, and here my argument is age. Now just notice that we are not passing any default values, or we are not passing any values to the arguments. We are just passing in an argument which will be assigned a value when you call the function. Now here we say age group is not defined, we say vote is not defined, and then we start using some condition checks. So I say if the age passed is greater than 18, then the age group would be adult and the person can vote, and message your age group is and voting status is will be printed out. So we can use this, or from our previous learning we can do a if else and modify the function. So let's create this function and then pass in a simple value to this, and that tells me what is your age group and what is your status to vote. So now if we would want to create a function to convert a name into uppercase, let's see how we can do that. So we are creating a function here which takes the value name. Now then we also find out the length of this particular argument, and for that we are using an inbuilt function called n characters, which will be for your name, and you would want to find out the length of this particular name, and we would say if the length is greater than 5, then we are again using an inbuilt function called toUpper, which will convert the argument or the name passed to uppercase. We will say message user given name is, and then you print out your name. So let's call in this function. So let me first create this, and then I can call in this function, and we clearly see that the number of characters in this word is more than 5, and that's why it is converted to uppercase. However, if you would call the function with a name which has less than 5 characters, it says as it is. Now this is again a simple function which we created. Let's see how you can create a function to calculate bonus. Now here we are passing in 2 arguments. So this function takes 2 arguments. One is salary and one is experience. And then we say if the experience is greater than 5, then bonus percentage will be 10, and else bonus percentage will be 5. And here we will calculate the bonus. So first it will find out how many years of experience a particular employee has, and based on that a value of bonus will be assigned, or bonus percentage will be assigned, and then you say what will be the bonus, that is salary into the bonus percentage, and return the bonus amount. So this is a simple function. Let's basically select this and let's create this function, and then let's calculate the function if the salary is 25,000 and experience is 6 years, and that basically will tell me the value. So let's look at the value. It tells me 2,500, which is 10% of the salary. Similarly, if we go for this one, which will basically go for the execution of else part of the code, we can do this, and that gives me bonuses half of it. Now how do we handle multiple conditions and multiple actions? So let's look at that. So let's create a function which takes one argument, which is age. We would check if the age is greater than 0. Then we would want a nested if within this condition. So if age is greater than 0, then whatever we have given here will get executed. And this will be this part of your code. And here I'm again checking if age is less than 18, then age group would be kids, else if. Now else if is to check the second condition. So if the age was passed, if it is greater than 0, then we get into this block of the code. Now it was greater than 0, but then is it less than 18? Then I would categorize the person as kids. If age is less than 60, then we will say age group adult, else we will say age group senior. Now we can basically say that we could have given more conditions to this, because here we are saying if age group is less than 18, then the individual would be within the age group of kids. If that is not true, that is it's not less than 18, so probably it is 18 or greater than 18, then we are checking the second condition. If the age is less than 60, age group is adult, and if these two conditions are not met, then it jumps to else, where age group is senior. And if this whole block was ignored because age was less than 0, then we would have just printed out age group is not defined, messages wrong age, and your age is such and such. So this is our whole function. So let's go ahead and run this. Now let's check the age group when the age is 10, when the age is 40, when the age is 65, or when the age is minus 10, which is not defined. Now there are some inbuilt functions which can be used in R, such as your switch function. So looking at this function, that is switch function, we can see, or we can use this for our different kind of operations. So here your switch function returns values match with the first argument, and first argument should be a character. Let's have a look at the example. So say for example you want to return the house rent allowance or HRA amount based on cities. So we create a function called HRA. Now that takes an argument which is city name, and here we will say what does this function do. So here I am saying HRA amount, and I'm going to use the switch function. Now switch function, I'm saying I would want to convert the city name to uppercase so that we can maintain some consistency. And here I'm saying if the city is Bangalore, it would be 7,500. If it is Mumbai, 1,000. If it is Delhi, 8,000. Chennai, 7,500. And you have 5,000 value. And you are returning the HRA amount. Now, what do we do with that? So let's create this function. It's done. And now we will pass in the value. So we will see whatever value has been passed to this, and that gives me the value here, right? So switch is basically taking me directly to this value. Now, however, if I try to provide a city name which is not given in the list, so when I'm saying, say for example, Pune, now what is happening is it is just taking a value which has not been assigned to any of these conditions. If I go for again something else which is in a lower case, now this is where your to upper function will come into use. And if we do this, it basically converts this into uppercase Bangalore, and then basically it gives you the value. So this is the usage of a switch function. Let's look at one more example. So for example, here we are creating a salary range, which will take an argument which will be band, and I will say these are my bands, or you can say these are my options. So I can say L1 is basically 10,000 to 15,000, L2 is so and so, and L3 is so and so, and you return the range. Now let's create this function. Sometimes you have to do it this way. So our function is created, and now we can just do a salary range given a value, and that gives me the range of the values. However, if you pass something which is not mentioned, then it basically prints out null. So in R, you can also use repeat, which can be useful. And what does repeat do? So here I am assigning a value to a variable called time. Let's do that. And then I'm giving a piece of code with repeat. Now what does repeat do? So you are passing in a message which is hello, welcome to our tutorial. And then you are saying if time is greater than or equal to 20, you would want to break out from this loop. And then you also increment the times value. And this will keep repeating till this if condition is met, wherein we have said time value starts from 15. So let's do this. And this basically will print out the message wherein first my time was 15, which was less than 20. So you increment it, it becomes 16, you print it again, 17, print it again, 18, print it again, 19 and 20. And as soon as you reach the times value, which is 20, it breaks out of this and it stops printing this particular message. Okay, now let's look at some more examples. So if you say R, we will use say a function to find the square of any given user number. Okay, if the square value is less than 100, then increment user value by 1 and find square again, and repeat this till square exceeds 100. Pretty simple. So you create a function which takes n as an argument and you would want to repeat it. So you would want to repeat this by squaring the numbers until the square exceeds 100. And once it reaches 100, you will break out. So this is what we are doing, and we are auto incrementing or incrementing the value of n by 1 every time we calculate a square, and then you return the value of n. So let's create this function, and now let's calculate it for square 6, and that tells me what is the square. Now as soon as your square value touches 100, it basically breaks out of the loop. Now, if you would want to find balance in a bank account after n years, if a person has deposited X amount in the beginning and bank gives a interest of 8% per annum, right? This is a simple calculation. So it needs the amount which was deposited, you need the year, and you need the rate. Now, year, which is n years, can be given by the user. Rate, we have already given 8%. However, functions main functionality is that you can even assign new values to it. Say later, 1 month down the line, the bank rate changes, might be it increases, might be it decreases, then function should not be modified. It can just take up the new values and start calculating from there on. Now here we will say get the final balance. Function takes amount, the amount which would be deposited, year, and that could be say 4 years or 5 years or 10 years for which you would want to calculate the rate of interest and add it to the amount. So I'll say for I in 1 to year. So that depends on how many times you would want to run this loop. I would say interest would be using the round function. I'm saying amount into rate, whatever is the rate of interest, and then you are giving 2 years. Now final amount will be calculated. So you are basically saying amount plus interest, and you will pass in a message where we'll say year is the value of I, that's first year or second year. Amount, what is the amount, what is the interest you are calculating based on the round function, and final amount will be amount plus the interest. And then you basically say amount will be given or final amount will be assigned to amount. Now if this is a function, you would want to return the final amount. So let's just select this and then basically create a function, and let's say I would want the final balance. If the amount deposited was 5,000, it was kept in the bank for 5 years and rate of interest was 8. Now that should basically give me my final amount. And if we double that, so we say amount is 10,000, number of years is 10, but the rate of interest is less. So let's calculate this, and that gives me the interest. However, if you notice, based on my message, it is basically telling me what was the first amount, what was the interest, what was the final amount. And it does that for all these number of years. So these are some simple examples for your functions, right? Now we can also look at, on the similar lines, we can create some interesting functions. So you can find the total number of years required to raise $1,000 if the user deposits $750 per month. So here you're not actually calculating the final amount, but you would want to find out how many years are required to basically have the amount as 8,000. So your function, we are saying the amount is say 550 or say 750 per month. Now I would say let the final amount be 0 as of now, month is 0, and I will say while my final amount is less than or equal to 8,000, I would want to do something, and that is you are incrementing the value of month by 1, because that's your first time your amount is less than 8,000, whatever deposit was made, say $750 per month. And then you have final amount, which is your initial amount, which has been assigned to F amount, that is 0, plus the amount. You print out the message, and then you basically say year is whatever value was passed for month. So you may want to have it for number of years or years with particular amount of month. So we will calculate the year value. Now here what we are doing is we are calling in this required years function without an argument, which takes the default argument, or you can pass it with 750. We can run this. So let's create this function. Pretty simple. Done. And if we do not pass an argument, then the amount is 750, and it tells me what would be or how much time it would take for us to reach from say 750 or 550 to final amount. Similarly, if I would have done this, it tells me again a new value. So we are finding out the total number of years required to raise 1,000 or raise the amount to $1,800. So these are some simple examples of functions which you can use for your operations, your calculations, and also creating functions which can be repeatedly used with either one, either no, or either multiple arguments. Now, so far we were learning on creating our own functions, and we also looked at using some inbuilt functions, either creating a plot or basically doing some basic operations or passing in multiple arguments. So let's look at some more examples. And when we talk about built-in functions, there are lots and lots of built-in functions which are available in R, which can be used. So let's look at these. So for example, here are some built-in functions which can allow you to work with different data structures. For example, you have a sequence function which allows you to create sequences. So for example, I could just say test nums, and I can just say sequence, and here I can say where does it start from. So might be I can say 0 goes all the way to 50, and then I can also say if I would want a jump or how many numbers should be used. So for example, let's do this, and now if I look at test nums, so that shows me the value. However, not to confuse, we could have also done this using assignment operator like this, and then look at your test nums. So it tells me it has created a list of numbers from 0 to 50 which are even numbers. Now you can always do a class of, and let's look at this, and that tells me the objects here are numeric, and say for example I would use type of, to see what is this test nums which we just created. There was a typing mistake. Let's check this, and it has the values with double, right? So we have created a sequence here where we are creating a list of numbers which have a space of 2, or you are saying about even numbers. Now you can also use a sort function. So I can do a sorting here, and I can give it in an increasing or a decreasing order. So if, for example, I have created this sequence, and I could just create a simple variable like this, pass in a vector into this, which could be, say for example, I'll try out test nums, and then look at your v. So those are my numbers, and you can straight away do a sort on your test nums. So I could just do a sort on v, and that basically shows me the number. However, I could also do a sort v, and then I could say here, let's check this v comma, and then you can say decreasing equals true, and let's do this. It just reverse or puts the data in a reverse order, or it sorts based on decreasing value and having the greater value in the beginning and the lowest value at the end. So you can use an inbuilt sort function. Similarly, you can use a reverse. Now reverse need not actually sort the values, it will just reverse the elements in your sequence. For example, let's say v2, and I will again use this one as C, and then just pass your test nums. That's an easier way. Or I could have created a new vector. So I'll say test nums. That's my v2, and you can do a reverse on v2, and that basically shows me the values. But here we see, let's see. So we are looking at, okay, so this was wrong. I should have given a capitals and do it. Yeah, this is fine. And we get the values. However, if I had created something like this, v3, and let's say C, and then let's say 99, and 2, and 3, and 4, and 5, and 78, 100. So that's a vector I'm creating. And now what I can do is I can use the reverse on v3, and you see it has just reversed the elements in the list. Now we could have done this without giving these brackets here, and it shows me the result. So this is good to understand what your sorting does. So sorting is basically going to look at the objects, and it's going to sort them in ascending or descending order. Reverse is just going to reverse the elements in your list. Now similarly, you can also use append, which is basically to combine objects. So let's say v4, and that will basically have append, and let's take v2, and let's take v3, and this is what we would want to append. And now look at your value of v4, which basically has everything added into one. So this is your append. Similarly, you have other functions like finding out the absolute value of a number. You would want to find out the square root. You would want to find the sum of all the elements in a vector. You would want to find out the floor value, exponential value of something, and you basically finding out the mean value. So these are some built-in mathematical functions. So you have built-in simple functions, you have mathematical functions, you have regular expressions in R, which can also be used for pattern matching. Now what we can simply do is we can create a variable. Let's say text, sorry for caps, let's say text, and here I will pass in something. R is a programming language for data science. Let's do this. And now I would want to use grep function. So I can say grep, and this one needs what I am searching for. So let's say language, and where am I searching for? So I'm searching it in text, and let's do that. And that tells me where is this found. So when I do a grep, I'm trying to find out if this was found in my element. So here I'm saying text and grep language. Similarly, I can also use one more function, which is finding out index positions. So I can also find out index positions by basically giving the vector, and here I can do a grep, pass in my vector a b c d. You are searching for b and in your vector, and that tells you your b is at the index position 2, d is at the index position 4. So here we are using some regular expressions. Now there are also other ways in which R can be used for data manipulation. So let's learn about factors in R, and how do you work with factors and what are they for. So when you talk about factors, so here let's clean this up and let's see what is this. So when you say factors, here we are talking about categorical variables. So categorical variables can take only limited number of different values. Now don't be confused with this histogram example here. Might be we can just look at packages so that that doesn't get confused. So when we talk about categorical variables, we are talking about variables which can belong to only categories. For example, in R, there is a data structure to work with these kind of variables, and that is called your factor. So with factors, we can be sure that all statistical modeling techniques will handle such data correctly. So for example, you can talk about a person's blood group, and you can say the blood group could be A or B or AB or O. So say we collected information about 8 people and we recorded this information as a vector, and we can call it blood group. So let's do that. So let me try that here. So if I say blood group, and then I would like to create a vector here so that we can look at information about 8 people and their blood group, and this can be in the form of a vector which can then be created or converted into factor by using the factor function. So how do we do that? Let's say I have blood group, and here I will basically give in some values. So I will use C function, and here let's give some values. So for example, let's say B, let's say AB, and let's say O, and let's say A again. Let's again say O, might be one more O. Let's say A, and let's say B. So here we have 8 entries, and let's consider we have recorded the blood group of 8 people, and this is in the form of a vector. So for example, let me create this. Now this is a vector which we have created, and you can always look at the value of this one. So let's say blood group, and that basically, okay, there was a spelling mistake. Let's do blood group, and that basically shows me the values. And here you see all the values that are in double quotes. Now we have basically created a vector. Now to convert this vector into factor, we can use the factor function. And how we can do that is basically we can say, for example, let's go here and let's say blood group underscore factor. And for to convert this vector into factor, I will use the factor function and then basically pass my blood group here. And now I have created a factor, and we can look at this factor by just doing an blood group factor. And now if you see, it basically shows us a factor. It does not have any double quotes, and you can also see the factor levels for categorical variables which get printed out here. Now what actually R is doing here is first R scans through vector to see the different categories in there. Then R sorts levels alphabetically, and then it converts the character vector to a vector of integer values. So these integers correspond to set of character values to use when factor is displayed. Now we can always do a structure to find out more details of this. And here I will pass in blood group factor, and let's look at this one. And this one shows me this factor is with 4 levels. So inspecting the structure will reveal that it has 4 levels. It shows me what are the categorical variables, and it shows me some integers. So here we are dealing with a factor of 4 levels. Now A's are recorded, and A would have, say, recorded as 1, so that would be a first level. You have ABs which are recorded here, and that is basically your second level. B is the third level, and O is the fourth level. So when we are looking at this factor, we may think, why this conversion? So categories could be very long character strings, and each time repeating a string or an observation can take up a lot of memory. So using factors and having these levels can reduce the memory space. Now factors are actually integer vectors, and each integer corresponds to a category or a level. Now to specify a different order of levels, we can specify levels inside the factor function. How do we do that? So let's say I will say blood underscore factor 2, and here I will basically give the same. So I'll say factor, and this factor will have blood group which we had created earlier, but this time also I'm going to specify levels, and then I can basically pass in a vector here. So within these levels I will specify the values. What are the levels? So here I will say O, then I'll say A, then let's say B, and then let's say AB. So this is what we are doing here to specify different order of levels, and we are specifying the levels here. Now if I do this, that would have got created, and let's look at blood factor 2, and that shows me the value here below where you have specifically assigned the levels. Now if you look at the previous one where we had blood group factor where levels were automatically understood by R, so we were looking at the categorical variables, we were seeing what are the levels here, and here what we have done is we have just created again a factor, but then we have specified levels in a different order, and you can obviously do a structure on this to compare. So for example, I'll say structure, and then I will say blood factor 2, and that basically shows me the structure with 4 levels. So this was the initial one where we said A, AB, B, and 0, and then there were some integer values which were responding to these categorical variables. Here we have given a different level, and we have a different set of numbers which we see here. So if we compare structure of blood factor and blood factor 2, we will see encoding is different, right? Now that is done. We can also specify the level names. So what we can do is, as we use names function for name of vectors, we can pass vectors to levels here, and there is basically a function what you can use. So let's say I will say levels, and then within this I'll pass blood underscore factor or blood group underscore factor here. So once this is done, let's say blood group. So in this one we created blood group underscore factor, and this one was blood factor 2, so that's okay. I mean, it's just a naming convention. And here let's pass in levels to my blood factor, and then what I can do is I can pass in the values here. So this is when you would want to give specific names, and let's create a vector, and let's call it say bt underscore a, and might be you would want to give bt underscore ab, and then you will give bt underscore b, and the final one is bt underscore o. So what I'm doing is I'm doing the naming for these particular categorical variables by using levels. Now let's do this, and it says blood factor not found. So we have to look which one did we have. So we have blood group factor. So this is what we should have given. So let's say blood group factor, blood group factor. And now we have given some names here. So let's look at the blood group factor now. Blood group underscore factor. And now if you see, we have some levels, or we have given the name to the categorical variable. So if you compare this one, so here we were creating a blood group where we had these variables, and these variables were the categorical variables, which was just creating a vector. Then we created a factor out of it, and then we looked at our factor, we looked at the structure of it. And similarly, what we did was we created a different factor. So let me also change the name here, and let me call it blood group factor 2, but here we were specifying levels in a different order. Let's look at this one, so which is blood group factor 2, and then you can look at the structure of this one, blood group factor 2. And here in this example, what we did was the initial blood group factor what we had created, we have just given some names to that, like what we would do in case of vector by using the names function. Here you're using the levels function. So we basically created some levels, and let's group at the blood group factor now, which basically has some different names. So what we are doing here is we are just using naming. Now we can also specify the categorical variable names or levels by specifying label arguments. So inside the factor function. So that is basically to give some names or levels. So let's look at this one. And how do we do that? So we can specify by using factor, which basically creates your factor. And then here I'll say blood group. I'm going to specify labels for my naming. So in previous examples, we saw how we were using the levels, right? And this was by specifying levels for a different ordering. And then we could have also done this by saying levels and given some different names, or we can just do labels, and then within this I will say labels equals, and then I can say C, and then let's give these values, which we have bt underscore a, bt underscore ab, bt underscore b, and o. So let me just copy this one again, and let's put it here, and then we can basically do a control enter. So I would have created a factor here, and then we should remember one thing here, that it is important to follow in the same order as the order of factor levels, that is a, ab, b, or o. Now these are the levels what we are seeing. So if you look at any one of these in the beginning which we had created, it was showing me what levels it has: a, ab, b, and o, and A, AB, B, and O. So we are following the same order, but we are using the labels within my factor creation. Now, sometimes there might be issues because of wrong ordering. So we can actually use a combination of manually specifying the levels and label arguments when creating a factor. Now, what we can do there is we can say factor, and in this case, let's say blood group, which I'm creating. Then I will basically say levels to give the right ordering. And here in levels, let's say O, let's say A, let's say B, and then let's say AB. So this is for my levels which I'm creating. And then what I can also do is I can go for labels. So levels will take care of my ordering and labels will take care of my naming the categories. So let's say labels, and then we can create a vector and we can give some names. So we can say bt underscore o. What else we have? We have bt underscore a. We can then say bt underscore b, and finally we can say bt underscore ab. And then let's create this one. So now what we have done is we have created a blood group which has levels, which is following your ordering, which is following the naming as we have passed. So if you look at the levels, it tells you the names what you have created. It also tells you all the categorical variables which were used for my blood group, and basically these will have some labels. So we can anytime look at our blood group which we had created in the beginning, and let's look at the values of those. So when we talk about categorical variables, there are two kinds in categorical variables. So you have nominal or you have ordinal. Now in nominal, you don't have any implied order. For example, blood group O is not necessarily greater than A. That is, O is no or not more worth than A, that we can think of. Now, trying such comparisons with factors will generate a warning. So, say for example, we would want to look into our blood factor, and let's look at what blood group factor contains. Now that's the new blood group factor. Let's say blood group factor, and here I will try to pull out a value here, and let's compare this with blood factor, and let's look at some other value. Now in this case we see not meaningful for factors, so it cannot really compare the categorical variables and see if one variable is greater than other or has more worth. Now there can be many examples where such ordering does exist, and in R we can impose such ordering in factors, thus making it ordered factor. So inside factor we can set the argument ordered is true, and we can do that. Now for example, you would look at the size of a dress. So let's say dress size, and here I will say, for example, let's create a vector, and let's say medium, let's say large, let's say small, let's say again small, and then let's say large, let's say medium, again an entry of large, and then let's say medium. So here I'm creating a vector, and let's see if we missed out any quotes or comma. So it says unexpected symbol, and where is that? So let's look at this one. So we have dress size, and we are looking at C. So I'm saying M, L, S, S, L, and here is a quote missing, and that was the reason. So, and this one also has a quote missing, and now it should resolve. Yeah. So let's look at this one, and now we have created a vector called dress size. Now obviously you can create a factor of this. So I'll say dress size underscore factor, where I would want to look at the ordering of this. So let's create a factor, and in factor we will pass our vector on which we want to convert, or we want to create a factor. We will say ordered equals true. So I am specifying a particular ordering, and then I can also specify levels as we saw earlier. So in levels we will give the categories. So what categories we have? So we have small, we have medium, and we have large. So these are the three levels which we have, and let's create this as a factor. Now that's done. And what you can do is you can look at the factor, and we can also do a comparison. So let's, for example, look at our factor. What does it contain? It has some levels, and if you closely notice, there are these levels which also have a comparison of which one is worth or more worth than other variable. So you can look at dress size factor, which has some ordering which we have implemented. And now let's do a comparison between dress size and compare it with some other variable and see what is the result. So now it says if it is true or if it is false. Earlier we were not able to do that because we did not have any ordering, and if we were looking at the variables, we were not really clear if one variable has more worth than others. So these are some simple examples what we have seen. Now we can also look at some more examples. So say for example I do a type here. Now that basically is creating a vector. If I would want to compare the element, that is type 3, is it greater than type 4? It shows me false, right? Now here what we are seeing is that if you are looking at a particular value, okay, we can basically see that there is some comparison happening here. If I compare this with 1 and 2, it tells me true or false. And if I look at this, it also does some comparison. So I can always convert this into factor by using the factor function. So I can do this. If I'm checking, if for example I would want to create a nominal factor, I can do a type dot factor and it tells me it is true. You can also do a type dot factor 2 and then use the factor function, pass in your type, which is a vector, and here you are saying ordered as true, which we just now saw. And now you look at type dot factor 2, which is creating an ordinal type of variables. Now here we can again create type dot factor 3. So what we are doing here, in this case, we had a vector. We basically said type dot factor. We said factor is of true. And then we looked at the nominal factor. We also did a factor 2. And then we created factor, but we specify ordered as true. So we get ordinal. And now if you look at type dot factor 3, here you are saying ordered, and you're also specifying levels like what we did in the previous example. And now you would look at ordered factor with user given order, which also has the levels which clearly show us a comparison between those. Now we can take a different example. We can say type dot factor 4. We are using the factor function. I'm specifying type, which is a vector. I'm saying ordered is t. I'm using level, which is giving me some levels. And then we also have labels, which are basically going to have the naming convention. So let's look at this one and look at type dot factor 4. So it tells me what are the categorical variables, which are small, medium, large, small, large, medium. These are for my type values, which we created a vector here. These are my type values for which we created a vector. We said ordered is true. The levels is small, medium, large, and we gave some names. So we are looking at the values of this. So this basically helps you to work on your categorical variables, wherein you can then compare the values and you can see what does it show. Now here what we are doing is we are creating a different vector. We say small, tall, tallest, medium, small, and so on. Let's look at this one, which is basically type and it has the value. So what we would want to do is we would want to compare height type of first value with the fourth value. So for that, let's create a vector on this type. Ordered is true. Level is we are saying small, medium, tall, and tallest. These are the levels. And now when you look at your type dot factor phi, it basically shows me what are the levels which you have specified. So small is the smallest, then you have medium, which is bigger than small, tall is bigger than medium, tallest is bigger than tall. We have assigned some levels, and based on these levels, now you can compare your values in this factor type dot factor 5. Take the first value, which is small, and compare it with the fourth value, which is medium, and you will know if small is greater than medium, so the result would be false. Now I can also convert this into integer, and I can continue working on this. Now here you have basically a sequence. So let's use the sequence function where I'm starting from 0 ending to 20, and there is a jump of 2, so that basically creates a vector. Let's look at the vector value here. And if you would want to sort the vector, so we are using a inbuilt function wherein let's create this vector with these numbers. I can do a sorting. I can also do a sorting with decreasing is true. You can do a reversing of vector. So these are some examples of inbuilt functions which we have already discussed. So here you are doing a reverse, you are finding out the structure, you want to append two vectors, you want to check the class of an object, you want to convert a vector into a list using as.list, converting the vector into a matrix, you are having a sample with two random values between 10 and 20. So these are some inbuilt functions which we have already discussed, such as your absolute, such as your vector and getting an absolute value, or getting a sum of it, or a mean of it, a round, or basically rounding it to two decimal places, getting the ceiling value, getting the floor value, truncating it, returning the log, getting the exponential value, and so on. Now, we have also looked at regular expressions earlier. So regular expressions, let's just revisit that. So here you are basically creating a variable called text, and then you can just do a grep. You can say what you would want to search and where you would want to search it, and that would give you the logical value indicating if the pattern was found. You can try to search something else which might not be found. You can also search for independent values like this, and that basically can give you the position of that particular object within the vector. And here is one more example of working with timestamps. So for example, if I would just do a sys.date, it returns the current system date. If I would want to set that as a variable and then call that variable, it shows me our current time. I can also use as date, and then let's look at this one. So as date, and this would be converted into date. And then you can obviously use formatting techniques like getting the month, getting the day, getting the year. So here we are passing in the date, and then we are saying what format we would be interested in, and that basically gives us the data in a particular format. So that's also useful when you have your time series data, or when you would want to convert the data types and so on. Now there are different ways in which you can do formatting. So for example, in this one we were saying month, day, and year. I can also say for getting the full month name or getting the full year name, I can do this caps. So I can look at this one, and that basically shows me my date in a particular format. So these are some inbuilt functions which we are seeing. And before this, we were seeing factors, which is mainly to work with categorical variables. Either they have levels auto assigned and they might not have labels. So you can give labels, you can give levels, you can control the ordering, you can give levels in a different way so that you can have a different ordering. So this is how you use factors and work on categorical variables, maybe that is nominal or ordinal, and easily you can do your statistical computations on such data. Let's learn about data manipulation in R, and here we will learn about dplyr package. And when we talk about this dplyr package, it is much faster and much easier to read than base R. So dplyr package is used to transform and summarize tabular data with rows and columns. You might be working on a data frame, or you might be getting in a inbuilt R data set, which can then be converted into a data frame. So we can get this package dplyr by just calling in library function, and this can be used for grouping by data, summarizing the data, adding new variables, selecting different set of columns, filtering our data sets, sorting it, selecting it, arranging it, or even mutating. That is basically creating new columns using functions on existing variables. So let's see how we work with dplyr. Now here I can basically get the package here. So I can just say install.packages dplyr. Now we already see the package here which is showing up. So I will just select this one. I can do a control enter, and that will basically set up the package dplyr successfully unpacked. So that is done. Now you can start using this package by just doing a library dplyr, and this was built. It shows me my version of R. So let's also use a inbuilt data set, that is New York flights 13. So we can do install.packages, and that will search and get that relevant data set. I can again call it by using library function. Now once that is done, we can look at some sample data here by just doing view flights, and that shows me the data in a neat and a tabular format, which shows me year, month, day, departure time, scheduled departure time, and so on. Now we can also do a head to look at some initial data, which can help us in understanding the data better. So what is this data about? How many columns we have? What are the data types or object types here? It shows me how many variables we have. So this is fine. Now we can start using dplyr, and in that we can use, say, filter function if we would want to look in for specific value. Now here we have the column as month, so I will do a filter. Now I'm creating a variable f1. I'm using the filter function on flights, which we already have. And then what we can do is we can basically look at the month, where the month value is 07. So let's look at that. And this one, you can do a view on F1, which shows me the data wherein you have filtered out all the data based on month being 7. So this is a simple usage of filter. We can take some other example. We may want to include multiple columns. So we can say F2 filter flights, and here we will say month is equal to 7, day is 3, and then look at the value of F2 if you are interested in seeing this, and that tells you the month is 7 and day is 3. You could also look into a more readable format by using view on F2, and that gives me my selected result. So we are just extracting in some specific value. We can keep extending this. So here we can say flights is what we would want to work on. I'm using the filter function, so I can straight away, instead of creating a variable then doing a view, I can also do a view in this way. I can just pass in my filter within the view, and within this I'm saying filter. I would want to look at the flights, month being 09, day being 2, and origin being LGA, and then that shows me the value here. And obviously you can scroll and look at all the columns, and if you see the origin column, it shows the selected value. So now we have filtered our data based on values in 3 different columns. Now what we can also do is we can use and, or we can use or operators. So I could have done this in a little different way. So I could have said head, which shows me initial result. I will do a flights. So within my head function, I'm passing in this. And what does that contain? So you are saying flights, and in this flights data set, you would want to pick up the month being the column. So we use the dollar symbol here. We give in a value, and I'll say and I'll again say flights, wherein I will select the day being 2 and remember, when you talk about it is going to check if all the values are met true. So then you say flights origin LGA and you look at the value. So in this way, I can filter out specifically multiple values by specifying columns. Now we could have done it in this way. We could have created a view, or we could have assigned this to a variable and then done a view on that, where we could have selected month being day and origin. Or you can be more specific in specifying all the columns. It makes the code more readable. So let's look at the values, and here you are looking at head, which shows me based on month, day, and then you can look for further columns for other variables, that is origin being LGA. Now what we can also do is we can do some slicing here to select rows by particular position. So I can say slice, and I would want to look at rows 1 to 5, and I can do this. So you can always assign or look at the view of this. I can just do here. So when I did a slice 1:5, it shows me my entries for 1 to 5. Now similarly, we can do a slice 5 to 10, and now you're looking at 5 to 10 values. So you can always look at the complete data and then you can slice out particular data. Now mutate is usually a function which is used when you would want to apply some variable on a particular data set, and then you would want to add it to your existing data frame, or you would want to add a new column. So this is where you use mutate, which is mainly used to add new variables. So let's see how you work on mutate. So it's pretty simple. So you create a variable over delay. Now I would want to do a mutate so that it adds a new column. So I'm selecting my data, which is flights. I will call the new column as overall delay, and then basically I can look at overall delay being arrival delay minus departure delay. So let's create this and let's look at view of this, which shows me, or which should show me, my new column, which is overall delay, which was not in my original data set. So you can anytime do a head on this one to compare the value. So this one shows me arrival delay, and then there are many other variables. What you can also do is you can do a view, and you could have just look at flights if you would want to compare. So you can look at the flights, and this one would not have any overall delay column. So it basically shows me 19 columns only, what we see here. And if you do a view on overall delay, then that basically shows me 20 columns. So we know that the new column has been added to this overall delay. So if you would want to work with 20 columns, you will use overall delay. If you would want to work with your original data set, you will use flights. Now you can also use a transmute function, which is used to show only the new column. So we can do an overall delay, and at this time we will say transmute, we will say flights overall delay. The computation remains same, but at this time if I look at view on overall delay, it only shows me the new column. So sometimes we may want to compute result based on two variables or two columns and just look at the new value, and then we can decide if we would want to add it to our existing structure. Now you can also use summarize, and summarize basically helps us in getting a summary based on certain criteria. So we can always do a summarize, and what we can do is we can look at our data and we can say on what basis we would want to summarize this particular data. So we can do a summarize function. Now summarize on flights, I will say average air time, and I would want to calculate an average. So for that, I'm using an inbuilt function called mean. I will do that on airtime column. So let's look at flights once again, and here we can see there is arrival time, not airtime, sorry, arrival time, and we would want to do some average on this particular data. We would want to summarize this. So what I'll do is I will use the summarize function. I will say average airtime, and this one I will look at mean of airtime. So let's see if there is a airtime column. I might be, let's look at this one, arrival delay, and yes, we have an airtime. So we were actually looking at summarizing based on airtime, not the arrival time. So airtime is how much time it takes in air for this particular flight, and we will want to use the summarize function, not the transmute. So summarize flights average airtime, and this one we will calculate the mean of average airtime, and I will also do a NA removal, which is I'm saying true. So let's do this. And that basically shows me the average airtime is 151. I can also do a total airtime where I'm doing a summation of values, or I can get the standard deviation, or I can basically get multiple values such as mean. I can say total airtime where I'm doing a summation, and then I can look at other values, which is if you would want to put in standard deviation here, you could do that. So let's look at the result of this summarize, and this basically allows me to get some useful information which is summarized based on a particular function such as mean, sum, standard deviation, or all three of them. Now let's look at grouping by. So sometimes we may be interested in summarizing the data by groups, and that's where we use the group by function. So we can always use the group by clause. Now here we are taking a different data set. So we will say, for example, let's look at head of empty cars, and that is basically my data set on empty cars. Now that shows me the model of the car, it shows me mileage, cylinder power, and your horsepower, and various other characteristics or variables in this particular data set. So here we can say let's do a grouping by gear. So there is a column called gear, so I will call it by gear. I will look at my data set, and then what I'm using here, which you see with these percentage and greater symbol, is called piping. So that basically feeds your previous data frame into next one. So this is sometimes useful, and you can get this by just saying Control Shift and M, and you can then use this. So we are going to have piping. So I'm saying empty cars. Now this is my original data set where I did a head, or I could have done a view on this one if you would want to see it in a more readable format, and that basically shows me the data. So we are using a different data set, so I want to group it by the gear column. So I'm going to call it by gear, and this one takes my data that is empty cars. I'm using the piping, and then I'm saying group the data based on gear column. That's done. Now let's look at the value of by gear, or you can always do a view. So remember, whenever you're doing a group by, it is giving you a internal object where your data is grouped based on a particular column. So we can look at the values here. You can do a view that shows you your data grouped based on a particular column. Now I can again use the summarize function where I would want to now work on the new one where it was grouped based on gear. So I'm doing a summarize, and here I'm going to say gear 1, which will be having the value of summation on the gear column, and then I'm saying gear 2, which is mean. Well, you could give some meaningful names to this, and let's look at the value of this one where we are basically now looking at the values, which is sum and mean values based on the gear. Similarly, we can look at different example. So we can say by gear, and I'm again using piping, but earlier we had taken gear we had grouped the data and we called it by gear. So we took our original data set empty cars, but now within this particular data, which was grouped by gear, I will take this data set, I will use the piping and I will summarize it where I am saying within this particular data set, I would want to get the sum or I would want to get the mean, and then you can look at the values. So what you're doing is you are either looking at your original data set or you're looking at the data which was already grouped, and then you can look at the values. Now here what we can do is we can group by cylinder. Say might be you are interested in looking at data which is summarized based on the cylinder column, you can do that. And then for this by cylinder, I'm doing a piping where I'm using the summarize function, and summarizing will then be done based on the mean values of the gear column or the horsepower. So let's do this, and then you can basically look at the value. At any point you may want to look at the data set again, so just do a head and you can look at what does the value contain, and by cylinder or by gear and do a head, and it gives you the value. So you can always do some summarizing or grouping in these ways. Now here we are going to use sample underscore n function and sample underscore fraction for creating samples. So for this, let's take the flights data set again, and we would want to get 15 random values. Now that is done, and it shows me 15 rows with some random values from the data. What you can also do is you can do a portion of data by using sample underscore fraction, and here I'll say flights, I'll say 0.4, which will return 40% of the total data. So this can be useful when you are building your machine learning, where you would want to split your data into training and test. Might be you are interested in some portion of the data, so you can do this, which is very useful function, and then you can look at the value of that. Now what we can also do is we can use a range function. So like we were doing a grouping by, or we were trying to pull out a particular column, so in the same way we can use a range, which is a convenient way of sorting than your base R sorting. So for a range function, let's do a view based on a range. So we will work on the flights data set which we have, and here what we would want to do is we would want to arrange the flights data set which is based on year and departure time, and we are doing a view out of it. So that basically gives me the data which is arranged based on your year and departure time. Now I can do a head to give me some highlighting of that data. Now the piping operator what we are using can be used in these ways also. So here I will say df, I will just assign the data set empty cars to it. Let's look at the df, which has basically your different models. You can obviously look at the head or view of it to look at useful information. We can also go for nesting options, which can be useful. So we are creating a variable called result here. Now that has the arrange function. So what does this arrange function do? So when we would want to use arrange to sort the data, so I would want to sort the data, but what data would I sort? So I will use sample n, which will give me some portion of the data or some sample data. Now what is that sample data? So here we are using nesting. That is, earlier when we did a sample, we just said data and how many random samples we want. But instead of giving that, what we are going to do is we are going to use filter here. Now this filter will work on df. So filtering will happen based on the mileage, which is greater than 20. I will say size is 5, and I would want to basically arrange this in a descending order. So I'm using the des on this particular mileage column. By default, it is always ascending. So let's get the result out of this, which will basically show me the mileage details in a descending order. So this is my data frame, and now we can look at the result what we have created. So just do a view or do a head and look at the view. So here you see mileage, where the highest value is on the top, and we were only interested in 5 values in a random sample. So that's why when you did a view, it shows your 5 values and it shows in a descending order based on mileage. So we have not only used an inbuilt function, we have not only arranged the data, that is, we have sorted the data, but we have sorted the data based on a descending order on a particular column. We have said the value should be greater than 20, and we have also said we just need 5 random samples. Now let's look at some other examples. So you can always do a multi-assignment. So I can say filter, wherein I'm going to use DF, which was assigned empty cars. I'm going to say mileage should be greater than 20. Then I say B, which is going to get a sample out of A, and I just want 5 random values. So let's look at that. So we have B, which is going to get a set of 5 values from A. Now I will create a result variable which will arrange B, which is sample data, in a descending order. Now let's look at the result of this, and that basically shows me what we were seeing earlier. So you can do a multi-assignment where you can create a variable, get a sample out of it, and then basically whatever is that result, you can arrange that or sort that in a descending or by default descending order. So same thing, we can do it using pipe operator. So piping. So here I will say result. I'm passing in my DF, that's the data set. I'm using piping, and which basically tells what you need to do on this particular data set. So I'm going to filter out the data based on mileage 20. Then I'm going to push that or forward it to get the random sample, and whatever is this random sample is going to be pushed. So you are arranging this in a descending order. So this is one more way of doing it, and then basically you can look at the result. So these are some simple examples where you can use your dplyr with multiple assignments, or using your nesting to filter out the data. You can also do a range, which is to sort the data. You can get some random samples out of it. You can summarize the data. You can also summarize the data based on 1 or 2 or multiple columns, and you can use some inbuilt functions to summarize the data based on some functions which are applied on the variables or on the columns. You can transmute it, where you would be interested in only looking at one column. You can mutate it, where you want to add a new column. You can slice it, and you can give the conditions where you can say and or to filter out the data. So what we can also do is, on this particular data set which we have, say for example DF, where I have my data. Let's look at this one, and if I just do a DF at this point, it shows me my data set. And if you would be interested only in particular column, then your dplyr also allows you to, either we can do a filter or we can simply do a select. Now for selecting, we can choose our data. So for example, I'll say df underscore, I'm interested in mileage, I'm interested in horsepower, might be I'm interested in your cylinders in this. And for this one, what I can do is, when I would want to do a select, I can basically say selected df, let's call it some name. I can say control shift m, which is for piping. And then basically what you can do is you can do a select, and you can choose your columns. So I was interested in mileage, I was interested in horsepower, I was interested in cylinder. And here what I'm doing is I'm using a select, where I can look at the new data frame. So let's do this, and I'm sorry, here we will have to give it df. This is where you are passing in your data. Yeah, now this one is done, and we can look at the value of this one by just doing a df or head on df underscore mileage horsepower cylinder and look at the selected result. So you can be looking at selective columns. I could have done this filter, but filter will always look for a condition. Say your mileage is greater than 20, or might be your cylinders are more than 4 or something else. But when you do a select, you are selecting specific columns. So view always gives you all the columns, head gives you highlight, but then select can be useful when we are interested in looking at only specific data. So this is how you can use dplyr for manipulation, for your data transformation, for basically filtering out the data by selecting particular data and then working on it. So similarly, there is one more package called tidyr, and we'll see how we can use data manipulation done using your tidyr package.
Let's learn about the tidyr package, which makes it easy to tidy your data. And this basically helps you creating a more cleaner data, so which is easy to visualize and model. Now this comes with mainly 4 functions. So you have gather, which makes your data wide, or it makes wide data longer, so that is basically used to stack up multiple columns. You have spread function, which makes long data wider, that is stacking the data together, or stack if you would want to unstack the data to data and you are talking about data which has same attributes, and then your spread can spread the data across multiple columns. You have separate, which is function which splits single column into multiple columns, and to complement that you have one more function which is unite, and that combines multiple columns into single columns. So these are 4 main functions which are used in your tidyr package. So let's look how we work with this. So let me bring up my R Studio here. Now for this, first is, let me just clean up my screen here, doing a Control L. So I will install the package. It is already installed, but we can just do a Control Enter, and then I can say, do you want to restart R prior to reinstall? So install, I'll say okay, and it is basically going to get the package. Now it says package tidyr, that is tidyr, has been successfully unpacked. Let's use that package using our library function, and that was built under R version 3.6. Now I can basically start using these functions. So for example, here we are creating a data frame. So let's say n is 10, and then we basically would say we will call it wide. Now that's the variable name. I'm using the data.frame function. I'm saying ID, which will be 1 to n. So that will take the values from 1 to 10. And then these are the values which have 10 entries. So this is a vector, phase 1, phase 2, phase 3. Let's create a data frame out of it. Now that's done. We can have a look at our data frame by just doing a view wide, and that shows me the ID column, and it has phase.1, phase.2, and phase.3. Now we can use our function. So for example, we can work with gather, that is reshaping the data from wide format to long format, and basically you can say stacking up multiple columns. So let's see how we do that. Here I'll call it long. I'm working on wide. I'm using the piping functionality, and then I'm using gather. So this one, I will say what will be the data which I will use. So we are using wide as a data frame. Then I'm saying response time. So that will be basically one more column. And then you have your columns which you would want to basically stack. So I'm saying from phase 1 to phase 3. So let's do this. And once this is done, let's have a look at our variable long. So this one shows me that I have an ID column, I have the response time column, and I have the phase column, which we mentioned, and that basically has all the values stacked in. So you have phase.1, phase.2, and phase.3. So all the columns are being stacked here. So all my data, so now I have totally 30 entries in this one. So this is basically using your gather function. Now sometimes we may want to use a separate function. Now, separate function is basically splitting a single column into multiple columns. So, which we would want to use when multiple variables are captured in a single variable column. Okay, so let's look at an example of this one. So let's say long separate, that's what we will call. We will work on this long, which has all the data stacked in as the columns we selected. Then I'm saying separate. I want the face column. And then I would say, when I separate the columns, what are my column names? Now I could also give a separator by giving a comma and then mentioning the separator if that is required. So let's do this. Now, once this is done, let's have a look at our long separate. So what we see here is the column which we used. So we were doing a face column and that was to be split. And we wanted to split it into target and number. So that's what we see here. So you have face being split into target and number, and then you have the response time. So this is how you use the separate function. Now there is also something called as unite function, which is basically a complementing of separate function. So it takes multiple columns and combines the elements to a single column. So for example, here we will call it long unite, and we will take long separate, which was separating the data. We want to unite, so we will take face, target, number, and we want to have a separator between them. So let's basically do this. And now let's look at the result of this unite. So you see, you have the face and target merged together. So you have face dot one, the separator is dot as we have mentioned, and we have united multiple columns. So this is one more function of your tidyr, which helps you basically tidy up your data or put it in a particular way. Now, then you have your spread function, and this is basically for unstacking. So that is, if you would want to convert a stack to data, or if you would want to unstack the data which is of same attributes, spread can be used so that you can spread the data across multiple columns. So it will take two columns, say key and value, and spread it into multiple columns. So it makes long data wider. So we can look at this one. We will say long unite. I'm using the piping. I will use the spread function. I'll work on the face column and response time. And let's do this. And then let's do a view on this. So it tells me our data is back in the shape as it was in the beginning. So these are four functions which are very helpful when we work with tidyr package.
So let's learn about visualization. And here we will learn about R, which can be used for your visualization. Now, one thing which we need to understand is, because of our ability to see patterns, which is highly developed, we can understand the data better if we can visualize it. So the efficient way or effective way to understand what is in our data, or what we have understood in our data, we should or we can use graphical displays, that is your data visualization. So there are actually two types of data visualizations. So you have exploratory data visualization, which helps us to understand the data, and then you have explanatory visualization, which helps us to share our understanding with others. So when you talk about R provides various tools and packages to create data visualizations, and which can be used for both kind of data analysis or both kind of visualizations. So when you talk about exploratory data visualization, the key is to keep all the potentially relevant details together. Now, the objective when we talk about exploratory data analysis is to help you see what is in your data. And the main question is, how much details can we interpret? Now, when you talk about different functions which we see here, such as plot, which is more for a generic plotting. You have bar plot, which is used to plot data using rectangular bars, or you can say creating bar charts. You have histogram or hist function to create histograms, where you look at the frequency of the data, or basically used to look at the central tendency of the data. You have box plot, which is used to represent data in the form of quartiles. You have ggplot, which is a package which enables the user to create sophisticated visualizations with the little code using the grammar of graphics. And then you have plotly or plotly. It creates interactive web-based graphs via the open source JavaScript graphing library. Now, before we see some examples here, let's also talk about, when you talk about plotting, let's also try to understand what kind of plots you can have and what kind of techniques you have. So let me open up my RStudio here. Now, for example, I can pull out a particular data set, and let's look at this one. So here I can look at all the panes, and that shows me the information. Now what I can do is I can install and get the inbuilt data sets, and then I can simply do a plot wherein I am doing a plot on chick-weight dataset. So let's see what does that show. It summarizes the relationship between four variables in chick-weight data frame, which is in R's built-in dataset package. Now from these plots, we can see, for example, weight varies systematically over time. You can also see that chicks were assigned to 4 different diets. Now, when we talk about explanatory data analysis or visualization, that shows others what we found in the data. This means we need to make some editorial decisions, what features we would want to highlight for emphasis, what features are distracting or confusing and you want them to be eliminated, right? So there are different ways of doing it. Now, when you talk about your graphics or visualizations, you have, I would say, 3 different types, or you can say 4. So you have the base graphics, which is easiest to learn. Now here we are having an example of base graphics where I can use the base graphics. I can get a data set using library. Then I can simply create using plot function to generate a simple scatter plot of calories with sugar from US serial data frame in the mass package, and then I can give it a title. So this is basically a simple example of base graphics. Now you also have what we call as grid graphics, which is powerful set of modules for building other tools. Now you also have lattice graphics, which is general purpose system based on grid graphics. And then you have your ggplot2, which implements grammar of graphics and is based on grid graphics. So you have different ways. Now here, since I already have used library and I have the data set, I can just do a X. So I can assign the sugar related values to X and calories related value to Y. Then I can use one more, which is library function and calling in grid. Now I can basically use functions such as push viewport if I would want to create a plot using your grid graphics to create the similar kind of plot which we created using base graphics, but this will give you much more power than base graphics. It will have a steep learning curve, but it is usually useful. So I can do this where I'm saying push viewport. Then I can basically say I would want to have a data viewport. I would say different functions of your grid package. So I'm saying rectangle, you have x-axis, y-axis, given some points here. And then basically you can add details to the graph by giving the names to the columns, and you can basically create a simple grid graphics based plot here. Now, there are different other options which we can use to create plots. Now, before we go into understanding how you create plots, let me just give you a brief on what are the different kind of plots and how they can be used. So here we will look at these different plots. Now, for example, we have a bar chart, which is a graph which shows comparisons across discrete categories. So you have x-axis, which will show the categories being compared, and y-axis, which represents a measured value, and height of the bars are proportional to measured values. Now, to create different kind of charts, you can use ggplot, which is a package for creating graphs in R. It is basically a method of thinking about and decomposing complex graphs into logical subunits, and that is a part of tidyverse ecosystem. So it takes each component of graph accesses, you can give scales, you can give colors, you can give the objects, and you can build graphs on particular data. You can modify each of those components in a way that's more flexible and user friendly. You can, if you are not providing details for the components, then ggplot will use sensible defaults, and this basically makes it a powerful and a flexible tool. Now here are different options when you use your ggplot, such as you can use geom, or what we call as geometric objects, to form the basis of different type of graphs. For bar charts, you have for line graphs, you have scatter plots, that is underscore point, you have underscore box plot for box plots, you have quartile for continuous x, violin for richer display of distribution, and jitter for small data. So here is some simple example where I would not go into too many details here, but you can just have a look at this one, where we are using library function to get the ggplot2 package. Then basically we would want to look into the mileage data. We would want to look at the structure of it. And then we can basically get the tidyverse package. Finally, we can create a bar chart using geom underscore bar, and we can basically also mention what would be in x-axis. Now you can also give different colors to basically add more meaning to your data. You could also go for stacked bar charts. So here we are actually telling ggplot to map the data in the drive column to fill the aesthetic. So here I am giving aesthetic access class, and I'm saying what is the data we need to have, and then we are using geom underscore bar. So you can also have dodged bar in your ggplot, that is not bar charts which are stacked but next to each other, and you can create that by using your position as position underscore dodge. Okay, now you can obviously use your different packages which are inbuilt, and you can create your bar charts. And you have other kind of graphs such as line graph, which is basically a type of graph that displays information as a series of data points connected by straight line segments, such as this one. And for this one we are using, if you see, geom underscore line. Now you can also create a scatter plot, which is a two-dimensional data visualization that uses points to graph the values of two different variables, one on an x-axis, one on y-axis, like what we saw in base graphics example. And they are mainly used if you would want to assess the relationship or lack of relationship between two variables. And you also have histogram, which I mentioned is mainly to look at the distribution of a data, to look at the central tendency of the data, basically looking at your large amount of data or for a single variable. You would be interested in saying where is more data found in terms of frequency, where is lesser data found in the graph, how close the data is towards its midpoint, or what we call as mean, median, mode. So you can use histogram, where you can categorize the data in what we call as bins. So these are some basics on different kind of graphs. Now we can look at some examples and see how that works. So what we were seeing is some quick examples of base graphics or grid graphics. Now here, let's do an example of pie chart for different products and units sold. So you want to create a graph for this. First, let's create a vector and pass in the value here. Now I can also create labels which I would want to assign to these values. And then basically I can plot the chart by saying pi. So that's the kind of chart which I would want to create. And I would say the data would be X and labels. So let's do this, and that shows me a simple pie chart. Now I can also give main details here. So instead of just doing a pie X comma labels, I can say what is the main and then what kind of coloring it should follow. So this is the way you can create a simple plot. Now I can also find out what is the percentage, And then basically I would be interested in plotting the pie chart, which takes X, which takes the labels, which will be the percentage which we are calculating here by doing a round function. And then you can basically give details to your graph. You can say what color it follows. You can basically look at the legend where it needs to be in your chart, what are the values, and then basically fill up the colors. So let's run this one, and that shows me the percentage which was calculated, and it gives me the details, and we can always have a look at our plot. Now if you would want to go for a 3D pie chart, then you can get the package which is Plotrix. Let's use that by calling in the library function. Let's pass in some data to X, and let's give some values or labels which will make more meaning to the data. And then let's plot the 3D graph. So I'm saying pi 3D here, where I'm using X and labels. Then I'm basically doing an explode, which will basically control how your graph looks like and basically give the values. So it also takes the title when you say main and pie chart of countries. Now let's create data for graph. So again, we are having a variable here. We are using the C function, creating a vector, and then let's create a histogram for this one, where I would say X lab, what would be your data around X axis, what is the color, what is the border, and here I'm creating a simple histogram, which, as I discussed earlier, will always show your values on the X axis, and Y axis is more of frequency. And then you can look at the set of values and what is their frequency, and we can basically use this histogram for exploratory data analysis, look at the data, try to understand what is the central tendency of your data values. Now we can also give some limits by using the X lim and Y lim, and then I can also specify what is the limit. So we have given some values here, wherein we have said your X limit is 0 to 40 and Y limit is 0 to 5. Now if you compare this with the previous one which we had created, this one based on the frequency had taken the limits, but we can assign limits explicitly by giving this and then create a histogram which makes more meaning. Now let's take another data set, that is air quality. Let's view this to see what does that data contain. So you have ozone, solar, wind, temperature, month, and the day. So this is the kind of information we have in the air quality. Now let's use the plot function to draw a scatter plot, where, as I mentioned, you would be interested in analyzing variables and see what is the relationship between them. So to plot a graph between ozone and wind values, so we will say plot, we will say the data which is air quality. From that I would be interested in the ozone column or ozone field and the wind field. I can create a plot based on this. Now I can also be saying what should be the color, what is the type of the data which you would want to create, and you can look at the information. So you can create a histogram, you can create a scatter plot to basically understand the data better and then infer some information from that data. So let's take the air quality data set itself without specifying any particular column, and you can create a plot which shows me all the different values which you have in the data, and it basically shows you the difference. This is more of an example like what we did for chick weight, where we did a base graphics. Now you can assign labels to the plot. So that is when you are creating a plot, you can say air quality, you will say ozone, and then that's your ozone concentration. You have your ylab, which is the number of instances. You have what is the title, ozone levels in New York City, what is the color. So these are the details what we have given with our plot function. And let's look at the data. So it just tells me that this is the ozone concentration, the number of instances what you have, and you are looking at the data. Now we could also create a histogram by picking up a particular column, that is such as solar, from your air quality, and that basically shows me the frequency of solar values, and we can then try to find out what is the mid, what is the mean, what is the standard deviation, and so on. You can also look at your histogram and try to understand if it is left skewed and right skewed. So we can do that. Now here, let's get the temperature out from this particular data set. Let's create a histogram on temperature, and that basically shows me the frequency of the temperature values and what values have the most frequency or most occurrence. Now you can create a histogram with labels. So let's do that with the limit, and then let's also use text to basically give in the values, which also takes the values, and for each set of frequency or each set of values it gives me the labels. Now you can have a histogram with non-uniform width, so you could do that by doing a hist function and then passing in your temperature. You can say what will be the main, what is the title, what will be your X lab. It will tell you a limit around x-axis, what is the color, what is the border, what are the breaks you would want to have for your bars, and you can simply create a histogram using this. So this basically takes the breaks which we have given, such as 55 to 60, 60 to 70, 70 to 75, and so on. So this is basically creating a histogram with non-uniform width, and it purely depends on the kind of values what you have. Now you can also create a box plot, which sometimes helps us in understanding the data quartiles, also understanding our outliers. So you can create multiple box plots based on the data from air quality. So we'll select all the data and then we'll do some slicing on the data. So let's create a box plot which tells me the values, and if you look at these points here, like single dots, these are basically your outliers. We can learn about that more in later sections. So you can use your ggplot2 library to analyze a particular data set. So for that, we will first use the install.packages and get ggplot2. So it says, do you want to restart R? And I can say yes. So let it get the package. I think the package was already there. And now let's look at using ggplot2. So for that, I have the library function, and let's do a attach where I'm getting a data set which is empty cars. Now then I will create a variable p1. I will use ggplot. I will pass in my data. I'll give the aesthetics, what is the columns which you would be interested in, and then you are using geom underscore box plot to basically create a plot which gives me the box plot for the values here, and this is based on the cylinders which is there in your data. So we can always look at what does our data contain and what kind of values or features are available in the data. Now let's create a box plot. We will also use the coordinate function, and that basically gives me based on the data. So I've changed the coordinates. Now if you look at the previous one where we created a plot, we had mileage on the y-axis and cylinders on the x-axis. Now I did a coordinate flip, and that's like your transpose function. So you have created the box plot, but you have just flipped the coordinates. You can create a box plot and then say fill, which is the factor of cylinder. So that can be used to fill up the values in your box plot. Now, what we can also do is we can create factors. So we have learned about factors earlier, which is usually used to work on categorical variables. So here, let's create a factor, which is empty cars gear. You have AM, you have cylinder. And if you look at the factors which we have created, we have passed our data. What is the field or the column we are interested in? What is the level of values there? And what are the labels for those values, right? So we have learned about factors. You can always look into the previous section and learn more about factors. Now let's create a scatter plot by using the ggplot function. Again, we will use the data as empty cars. I will go for mapping option, and then I will give my aesthetics, that is what would be X, what would be your Y, and you also would want to use what kind of function you are using. So let's go for point, and that basically helps me in creating a scatter plot. Now you can create a scatter plot by factors. So here we will say ggplot. So notice in all of these cases, depending on the kind of data you have, depending on the kind of plot you are interested in, you will use the ggplot and then basically a function with that or the inbuilt package. So here I'm saying data is empty cars. I'm going for mapping, which basically will take the values for your X and Y. What is the color? And the coloring will be done based on the factor values. Now, if you remember, factors will obviously have some levels, and those levels will basically help you in differentiating between your categorical variables. So I'm saying as dot factor on cylinder, and then I'm using point to basically create this scatter plot. So let's do this, and I can look at the values of this one. So it says must be, there is an error which says must at least one color from the hue palette. So let's look at that one. So the error which we were facing when we gave color as the factor values was because when you look at these factors which were created with some labels, if we look at the values of these, it tells me there are NA values in that particular column. Similarly, your gear, or similarly, you can completely look at the complete data set. It tells me cylinder, you have AM, you have gear. Now these have some, we have created some labels, but these have NA values. So what we can do is we can create a scatter plot as we did earlier by giving the aesthetics, and that's a simple scatter plot wherein I'm also using point so that I can have these points by defaults or with defaults. You can also give a color specific, basically if you would want to have different kind of data in the same plot, or I can create scatter plots by different sizes by giving a size, or I can give a color and size, and that's again one way in which you can create your scatter plots. Now let's also see how you can visualize one more data set, which is MPG. So I can also do it in this way where I set ggplot2 and then pass in, look at the data set what we have here. You can just do a view on this to see what my data contains, if the fields have any NA values, if that's going to affect your plotting. So now what we can do is we can create a bar plot or a bar chart. So I'm saying ggplot, the data would be as we have given in previous lines, that is ggplot2 mpg. Then I will say what should be in my aesthetics and what kind of chart are you going to create. So I'm saying geom underscore bar. So that's my bar chart, and that has basically your class and count. Now you can create a stacked bar chart where your information is stacked in the same bars, and we are still using the same data. We are going for aesthetics, which is class, and then when you say geom bar, which creates your stacked bar, we will use fill, which is drive. And we can always go back and look at our data. For example, you can always look into this. So you have the drive column here, and you are also working on this complete data set. So let's go ahead and create a stacked bar chart. And that basically gives me the information where you have the drive information, which is stacked here. Now you can do a dodge by giving the position as dodge. So we are still going to go for a stack chart, but this time the bars will be next to each other, and that can also be done, which is very useful. You can use this by using geom point where you are mapping and you are specifying what are your aesthetics. So we were creating a scatter plot. Now you can also use or give more details where you can say color can be based on the class, and we have different classes, and based on that my points have been colored. Now you can also use a plot ly or plotly library. So let's install this one. I will say yes, for example. Let it basically restart so that all my packages are updated. Then I can access that package using library function, and then create a variable to which you are assigning your plot underscore ly plot. So data is empty cars. What will be your x-axis, what will be your y-axis, and details on your marker which we have given, wherein I will give a list which is size, color, which is a combination, and then you have your line, what kind of color it will have, and what will be the width. So this is where I'm going to use plot ly, and let's look at this plot. So it basically gives me some information. Now we see some warnings which are getting generated, but you don't need to worry about that. So you can look at the packages, what you have, and what options you are using. So similarly, we can create one more plot using plot ly and look at the values of those. So that's a plot with a trend which explains me about my data. So this is a simple small tutorial on understanding or how you can have your graphics or visualization used to understand your data. Obviously, there are much more examples, much more ways in which you can pass into your plot functions or your ggplot and the inbuilt packages which are available in R for your visualization. Now that could be for exploratory data analysis or explanatory data analysis. So try these graphs and see if you can change these options and try or create new visualizations.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.